Okay, so here we are at the Natural History Museum Gardens. Tell us a little bit about the sensor network that's going in.
So we're building out a network of about 25 sensors, monitoring the environment, so temperature, humidity, light levels across our site, and also focusing on acoustics, so picking up sounds made by animals, traffic in this environment, and working out how our activities in the garden and noise from the environment affects the animals that live here.
Okay, so we're collecting lots of different types of data, and what are we hoping to learn from all of this?
So we're trying to create an environment where we can thrive as people and the wildlife around us thrives. So it's looking at what can we do to keep our cities cool. So we're in the middle of a climate emergency. Cities are hotter than the surrounding environment, so we need to keep them cool so that we can live, we can thrive, but also nature can thrive. And using the acoustics, we can look at how, say for example, birds are affected by the traffic here. It's quite a noisy site.
Yes.
And by people. There's also a lot of people here during the day. So we start to understand how our activities impact nature and what we can do to mitigate it.
Yeah, because I think, as more and more people live in cities, most people live in cities today already, it's super important to understand what's the right level of interaction and intervention to make sure that people and planet thrive and live in harmony together.
Yeah, and people won't protect what they don't understand. So exposing children or getting kids involved and excited by nature is really important.
Yeah, absolutely. Kids who are less connected to nature are less inclined to protect it, and that's a really scary thought otherwise. But when we're talking about bioacoustic data that we're capturing, what are we listening to? So there's obviously traffic, we're listening to sounds in the ponds, what else?
So listening in ponds, there's lots going on in ponds.
Okay.
We're also listening in environments which it's hard to look into. So we're trying to get a comprehensive survey of the site, understand what's here, what's happening in these ecosystems. So we're looking in soil, inside rotting wood, listening inside trees, and combined with other tools like environmental DNA, we can start to build a comprehensive picture of these environments which are hard to study just by looking at them.
Yeah, and I think that's where the data ecosystem really comes to play, where you're able to bring all of these different types of data sets together to build a much more comprehensive picture. Instead of just listening to one thing or looking at one area, we're able to take that holistic view, right?
Yeah, and lots of these environments are hard to study, and using this kind of suite of techniques, we can go, what's the most appropriate?
Oh, little froggy.
What's the most appropriate tool for a particular place or a particular time?
Yeah, and I think that's where the power of the partnership between Amazon Web Services and the Natural History Museum is really unique, because we're really bringing the best of our capabilities together to help accelerate scientific research.
Yeah, so the kind of work we do is very data rich. So even without all these digital tools, it's a very data rich environment, collecting all these things like what occurs where. And then to accelerate that, we really need to understand a lot of data science and bring these two kind of communities together, so that we have experts in technology and experts in the natural world working together to solve our most important problems.
We might not have 350 scientists at Amazon Web Services, but what we do have are the technology capabilities to help you guys accelerate your research, do things faster, look at things in a way that you weren't able to do before. And that's really the aim of this partnership, right? Which is to meet those urgent challenges that we have in climate, in biodiversity, in nature, to really help us restore UK's nature and biodiversity in the first instance, but then also hopefully inspire other parts of the country as well as other cities around the world, because this is a really unique kind of living lab that we have here.
Yeah, and we had the chance when we were building the gardens to install all this stuff from the ground up, right? So it's not possible to do this in the way we've done it in many gardens, let alone out in the wild. But the understanding we get from having such a rich data network, we can take that to places where it's harder to work, where we don't have permanent power or permanent data.
Yes.
How do we operate in those environments? And the understanding we get here, which is all of its rich data streams, would really help us in other environments where data is a bit harder to come by.
Yeah, and I think we love to think big, start small, and this is where we're able to really start developing that understanding to inform, what are those next steps? What should we be doubling down on to help us improve nature and biodiversity? What are the things that we might need to course correct? And that starts to really help businesses as they set their corporate goals around how they can really support and help the natural environment thrive.
So it's really important we have strong evidence-based policy, and that requires robust research, which requires lots of robust data, which is step one.
So this is only just the beginning. We're very excited to see how this project continues to grow and how all the data we start to capture from the sensors will tell us more of what we need to know.
Yeah, it's a very exciting time to have this partnership.
Great. It was lovely chatting with you, Ed.
Thank you.
See you soon.